Have you ever wondered why the second the weather gets a little colder, it feels like everyone starts getting the sniffles? Well, today we're going to pull back the curtain on this amazing link between what you eat, the temperature outside, and your body's power to fight off sickness. And believe it or not, it all starts deep inside your cells.
It's a question we've all asked ourselves, right? Is it just something people say, or is there a real biological reason we feel a bit more vulnerable when the temperature drops? Well, in this explainer, we're going to dig in and find the answer at the microscopic level.
So here's our roadmap for solving this mystery. First, we'll tackle the winter cold mystery head on. Then we'll zoom way into the cell's communication hub to get a handle on the core of life fluidity. After we figure out what makes cells stiff, we'll wrap up with something you can actually use, a diet for fluidity.
Okay, let's dive in. Our journey really starts by just appreciating the absolutely incredible work our cells are doing, like right now, every single second. You've got this coordinated, invisible army working around the clock to keep you healthy, and you probably don't even notice. I mean, think about it. You get a tiny little paper cut. Seems like no big deal, right? But inside your body, it is all hands on deck. Platelets are rushing over to stop the bleeding. Immune cells are on guard, fighting off any bacteria trying to sneak in. And your skin cells immediately start this complex project of rebuilding. All of this depends on nonstop, crystal clear communication between millions of cells. So where does all this cellular chatter actually happen? It's all going down at the very edge of the cell, on something called the cell membrane. Now, don't picture a hard, rigid wall. It's much more like a dynamic, fluid, kind of oily sea, and it's absolutely essential for sending and receiving messages. This breakdown is pretty fascinating. You see, the membrane is more than half protein. Those are like the antennas and the doorways for all that communication. But the foundation they're all floating in, that oily sea, is made of fats like phospholipids and cholesterol. And this exact mix is the secret to, well, everything.
And this is really the most important part. Those proteins and fats aren't just locked into place. For your cells to talk to each other, to bring in nutrients, and to fight off invaders, everything in that membrane needs to be able to move around freely. This vital property has a name: fluidity.
Think of it this way. A nice, fluid membrane is like a busy harbor, with boats moving around, constantly delivering goods, sending messages. It's active. But a rigid, stiff membrane, that's like the same harbor frozen solid. Nothing can move. Everything grinds to a halt. That's just how critical fluidity is for your cells to do their jobs.
And this visual just lays it out perfectly. On the left, you've got a healthy, fluid membrane. This allows for a super fast and strong immune response because all the communication channels are open for business. But on the right, a rigid membrane just slows everything down to a crawl. Communication breaks down, and your body's defenses get weaker. Okay, so if being fluid is so important, what actually causes a healthy membrane to lose that property and become stiff? Well, it turns out there are two major culprits that we all encounter pretty much every day. First off, just like butter gets hard in the fridge, the fats in your cell membranes literally pack together more tightly when the temperature drops. So this directly answers our big question from the beginning. Cold weather can actually make your immune cell membranes more rigid, slowing down how fast they can respond. The second big factor is the kind of fat we eat, since those fats become the actual building blocks for these membranes. And here's a bit of a plot twist. We're always hearing that cholesterol is bad, but inside your cell membrane, it's basically a superhero. It acts like a little spacer, getting in between the fats to keep them from packing too tightly when it's cold. But it also helps hold them together so they don't get too loose when it's hot. It's the ultimate fluidity buffer, keeping your cells in that perfect, just right state. And this brings us to the most empowering part of this whole story. Look, we can't control the weather, but we absolutely can control the building materials we give ourselves. We can literally build better, more fluid cell membranes based on the fats we choose to eat. This table basically lays it all out for us. It's a power ranking for fats. At the top, you've got the fats that help your cells stay fluid and flexible, and at the bottom, you've got the ones that cause them to stiffen up. So let's break down what these are and where you can find them. So the real heroes for cell fluidity are the unsaturated fats. We're talking about the stuff you find in fatty fish, avocados, nuts, and olive oil. So why do they work so well? Well, at a molecular level, they all have a natural kink, or a bend in their shape. This bend creates space, which stops them from packing together too tightly. It's what keeps your cell membranes loose and flexible. Now, on the flip side, saturated and trans fats are the ones you want to be more mindful of. These fats are molecularly straight, like a bunch of logs that you can stack perfectly together. When these get built into your cell membranes, they pack together really densely, and that leads directly to those rigid, poorly functioning membranes that can weaken your immune system.
You know, this quote really just says it all, doesn't it? What you eat doesn't just give you energy for the day. It literally becomes you. The fats you eat are the direct building blocks for the membranes of every single one of your trillions of cells, and that directly impacts how well they can do their jobs. So, as we wrap up, I just want to leave you with this one thought. The next time you sit down for a meal, just think about this. Are you choosing the building blocks for flexible, fast communicating, and resilient cells? Or are you choosing the blocks for rigid, sluggish ones? The choice is totally yours, and it's one of the most powerful decisions you can make for your health. Thanks for joining me.